This is my grandfather, and this is my son. My grandfather taught me to work with wood when I was a little boy. And he also taught me the idea that if you cut down a tree to turn it into something, honor that tree's life and make it as beautiful as you possibly can. My little boy reminded me that for all the technology and all the toys in the world, sometimes just a small block of wood, if you stack it up tall, actually is an incredibly inspiring thing. These are my buildings. I build all around the world out of our office in Vancouver and New York. And we build buildings of different sizes and styles and different materials depending on where we are, but wood is the material that I love the most. And I'm going to tell you the story about wood. And part of the reason I love it is that every time people go into my buildings that are wood, I notice they react completely differently. I've never seen anybody walk into one of my buildings and hug a steel or a concrete column, but I've actually seen that happen in a wood building. I've actually seen how people touch the wood, and I think there's a reason for it. Just like snowflakes, no two pieces of wood can ever be the same anywhere on Earth. That's a wonderful thing. I like to think that wood gives Mother Nature fingerprints in our buildings. It's Mother Nature's fingerprints that make our buildings connect us to nature and the built environment. Now, I live in Vancouver near a forest that grows to 33 stories tall. Down the coast here in California, the redwood forest grows to 40 stories tall. But the buildings that we think about in wood are only 4 stories tall in most places on Earth. Even building codes actually limit the ability for us to build much taller than 4 stories in many places, and that's true here in the United States. Now, there are exceptions, but there needs to be some exceptions, and things are going to change, I'm hoping. And the reason I think that way is that today, half of us live in cities, and that number is going to grow to 75%. Cities and density mean that our buildings are going to continue to be big, and I think there's a role for wood to play in cities. And I feel that way because 3 billion people in the world today, over the next 20 years, will need a new home. That's 40% of the world are going to need a new building built for them in the next 20 years. Now, 1 in 3 people living in cities today actually live in a slum. It's 1 billion people in the world live in slums. 100 million people in the world are homeless. The scale of the challenge for architects and for society to deal with in building is to find a solution to house these people. But the challenge is, as we move to cities, cities are built in these 2 materials, steel and concrete. And they're great materials. They're the materials of the last century. But they're also materials with very high energy and very high greenhouse gas emissions in their process. Steel represents about 3% of man's greenhouse gas emissions, and concrete is over 5%. So if you think about that, 8% of our contribution to greenhouse gases today comes from those 2 materials alone. We don't think about it a lot, and unfortunately, we actually don't even think about buildings, I think, as much as we should. This is a US statistic about the impact of greenhouse gases. Almost half of our greenhouse gases are related to the building industry, and if we look at energy, it's the same story. You'll notice that transportation is sort of second down that list, but that's the conversation we mostly hear about. And although a lot of that is about energy, it's also so much about carbon. The problem I see is that ultimately, the clash of how we solve that problem of serving those 3 billion people that need a home and climate change are head-on collision about to happen, or already happening. That challenge means that we have to start thinking in new ways, and I think wood is going to be part of that solution. I'm going to tell you the story of why. As an architect, wood is the only material, big material, that I can build with that's already grown by the power of the sun. When a tree grows in the forest and gives off oxygen and soaks up carbon dioxide, and it dies and it falls to the forest floor, it gives that carbon dioxide back to the atmosphere and into the ground. If it burns in a forest fire, it's going to give that carbon back to the atmosphere as well. But if you take that wood and you put it into a building or into a piece of furniture or into that wooden toy, it actually has an amazing capacity to store the carbon and provide us with a sequestration. 1 cubic meter of wood will store 1 ton of carbon dioxide. Now, our two solutions to climate are obviously to reduce our emissions and find storage. Wood is the only major building material I can build with that actually does both those two things. So I believe that we have an ethic that the earth grows our food, and we need to move to an ethic in this century that the earth should grow our homes. Now, how are we going to do that when we're urbanizing at this rate and we think about wood buildings only at 4 stories? We need to reduce the concrete and steel. We need to grow bigger, and what we've been working on is 30-story tall buildings made of wood. We've been engineering them with an engineer named Eric Karsh who works with me on it. And we've been doing this new work because there are new wood products out there for us to use, and we call them mass timber panels. These are panels made with young trees, small growth trees, small pieces of wood glued together to make panels that are enormous, 8 feet wide, 64 feet long, and of various thicknesses. The way I describe this best, I've found, is to say that we're all used to 2x4 construction when we think about wood. That's what people jump to as a conclusion. 2x4 construction is sort of like the little 8-dot bricks of Lego that we all played with as kids, and you can make all kinds of cool things out of Lego at that size and out of 2x4s. But do you remember when you were a kid and you kind of sifted through the pile in your basement and you found that big 24-dot brick of Lego? And you were kind of like, cool, this is awesome, I can build something really big and this is going to be great. That's the change. Mass timber panels are those 24-dot bricks. They're changing the scale of what we can do, and what we've developed is something we call FFTT, which is a Creative Commons solution to building a very flexible system of building with these large panels where we tilt up 6 stories at a time if we want to. This animation shows you how the building goes together in a very simple way, but these buildings are available for architects and engineers now to build on for different cultures in the world, different architectural styles and characters, in order for us to build safely. And we've engineered these buildings actually to work in a Vancouver context where we're a high seismic zone, even at 30 stories tall. Now, obviously, every time I bring this up, people even, here at the conference say, are you serious? 30 stories? How's that going to happen? And there's a lot of really good questions that are asked, and important questions that we spent quite a long time working on the answers to as we put together our report and the peer-reviewed report. But I'm just going to focus on a few of them. Let's start with fire, because I think fire is probably the first one that you're all thinking about right now. Yeah, fair enough. And the way I describe it is this. If I asked you to take a match and light it and hold up a log and try to get that log to go on fire, it doesn't happen, right? We all know that. But to build a fire, you kind of start with small pieces of wood and you work your way up, and eventually you can add the log to the fire. And when you do add the log to the fire, of course, it burns, but it burns slowly. Well, mass timber panels, these new products that we're using, are much like the log. It's hard to start them on fire, and when they do, they actually burn extraordinarily predictably. And we can use fire science in order to predict and make these buildings as safe as concrete and as safe as steel. The next big issue, deforestation. 18% of our contribution to greenhouse gas emissions worldwide is the result of deforestation. The last thing we want to do is cut down trees. Or the last thing we want to do is cut down the wrong trees. There are models for sustainable forestry that allow us to cut trees properly, and those are the only trees appropriate to use for these kinds of systems. Now, I actually think that these ideas will change the economics of deforestation. In countries with deforestation issue, we need to find a way to provide better value for the forest and actually encourage people to make money through very fast growth cycles, 10, 12, 15-year-old trees that make these products and allow us to build at this scale. We've calculated a 20-story building will grow enough wood in North America every 13 minutes. That's how much it takes. The carbon story here is a really good one. If we built a 20-story building out of cement and concrete, the process would result in the manufacturing of that cement in 1,200 tons of carbon dioxide. If we did it in wood, in this solution, we'd sequester about 3,100 tons for a net difference of 4,300 tons. That's the equivalent of about 900 cars removed from the road in 1 year. Think back to that 3 billion people that need a new home, and maybe this is a contributor to reducing. We're at the beginning of a revolution, I hope, in the way we build, because this is the first new way to build a skyscraper in probably 100 years or more. But the challenge is changing society's perception of possibility, and it's a huge challenge. The engineering is, truthfully, the easy part of this. And the way I describe it is this. The first skyscraper, technically, and the definition of a skyscraper is 10 stories tall, believe it or not, but the first skyscraper was this one in Chicago, and people were terrified to walk underneath this building. But only 4 years after it was built, Gustav Eiffel was building the Eiffel Tower. And as he built the Eiffel Tower, he changed the skylines of the cities of the world, changed and created a competition between places like New York City and Chicago, where developers started building bigger and bigger buildings and pushing the envelope up higher and higher with better and better engineering. We built this model in New York actually as a theoretical model on the campus of a technical university soon to come. And the reason we picked this site to just show you what these buildings may look like, because the exterior can change, it's really just the structure that we're talking about. The reason we picked it is because this is a technical university, and I believe that wood is the most technologically advanced material I can build with. It just happens to be that Mother Nature holds the patent, and we don't really feel comfortable with it. But that's the way it should be, nature's fingerprints in the built environment. I'm looking for this opportunity to create an Eiffel Tower moment, we call it. Buildings are starting to go up around the world. There's a building in London that's 9 stories, a new building that just finished in Australia that I believe is 10 or 11. We're starting to push the height up of these wood buildings, and we're hoping, and I'm hoping, that my hometown of Vancouver actually potentially announces the world's tallest at around 20 stories in the not-so-distant future. That Eiffel Tower moment will break the ceiling, these arbitrary ceilings of height, and allow wood buildings to join the competition. And I believe the race is ultimately on. Thank you.